Welcome back to Pharma-info with Shubhashish. Now today's topic is narcotic analgesic, right? I have written an example of narcotic analgesic here. There is fentanyl citrate, and we all know that narcotic analgesics, they are basically born out of morphine, right? So morphine was found to be the lead, okay, and from the structure of morphine, with all those informations and all, researchers, they developed so many narcotic analgesics, right? And one of the drug that is still in use, that is called fentanyl citrate. So we can just put this particular drug under the category of narcotic analgesic, right? So this is found to be the category narcotic analgesic. That means they are producing analgesia, right? Analgesia by acting on central nervous system, right? Or we can also call it as centrally acting analgesic, right? Chalo. So now what exactly we are going to do? Shall we go after the pharmacological aspects? No, definitely not, right? So we'll see the making, that means the synthesis of. So here we'll just deal with the synthesis of fentanyl citrate, right? So likewise, let us proceed. So we all know that the protocol, the basic protocol is, first let us deal with the structure, then we'll move to the IUPAC name, and later on we'll see that what are the different components which are associated in making fentanyl citrate, right? Chalo. Now let's move on to fentanyl citrate, the structure and all, right? Okay. So only thing is that can be extracted from the name, that is fentanyl citrate, fen for phenyl, right? So we have only one clue that we got, that is found to be phenyl, right? So this is there, and the other thing, that is the salt of citric acid. So that is why. So these are the clues. These are two, structural information that we can get from the name itself, right? Okay, that means the usual strategy says, from that usual strategy, or opting the usual strategy, we got two informations. One is of the acid with which the salt is being formed, and the other one is the phenyl is found to be one of the key member of the fentanyl citrate. Now let's move on to the structure now. Right. So what about the structure? The structure is something like, okay. So we have a H5C2, then C double bond O. Then we have a nitrogen, right? So that means thus we have got an amide, like a amide kind of things and all, right? To this nitrogen, one hydrogen or one phenyl has already been inserted. Now later on, and the other end, the final end has to be inserted with what? Inserted with the piperidine. To this piperidine, this phenethyl is attached, right? Right. So this is all about the fentanyl, and citrate means this dot. So we have to put something like CH2COOH, and CHCOOH, and then CH2COOH. Strivoic acid, right? So this is about your fentanyl citrate. Now we are less concerned about this particular portion, that is citric acid and all. We all know about citric acid. We'll just see that how the nomenclature can be developed from the structure itself, right? Okay, chalo. So first and foremost, in the process of naming the name and all, first and foremost we have to focus on what? We have to find the parent one, right? So here the parent one is found to be the CON, that means the amide. And we'll just take the longest chain. Here the longest chain is found to be something like this. So this amide comprised of how many atoms? 1 and 2. That means 3. So 3 for pro. So that means the parent is found to be propanamide. To this propanamide, the nitrogen is found to be di-substituted. We have a substitution here as phenyl. So N, this is one of the substituent, right? The other one is found to be, the N is holding another one, that is piperidine. To this piperidine, the first nitrogen is holding what? Phenethyl. Phenethyl, or 2-phenyl ethyl. So likewise, this is the portion which can be written as, how this can be written? N. Then what? Put a third bracket. To this third bracket, we'll just put a 1. Then this is 1, 2. 2 phenyl ethyl, close the bracket. So 1 of what? So this is the 1. That means the first position of this piperidine is inserted with a phenethyl. We are done with this. Then we have to complete this one. Then basically this is 4 piperidine 4 aryl, because this is acting as a substituent, right? So right, likewise, after once we are done with this phenethyl and all, then we'll write piperidine then 4 aryl. So we are done with the major substituent. This is found to be the major one, right? Compared to this, this is only a phenyl. This is found to be the major one. So the major one is the N of what? The substituted amide, right? So N is holding what? 1. 1 means the first position of this piperidine. Holding what? Another substituent. The substituent is what? 2-phenyl ethyl. Likewise, I have written 2-phenyl ethyl. That should be in a parenthesis, right? And then moving on, this is the piperidine is not found to be a parent here. The piperidine is found to be a substituent here. So that is why I have written here piperidine then 4-aryl, because it is the 4th carbon that is directly connected to this nitrogen. So that is why I have written here piperidine 4-aryl, right? So we are done with this. Then this also starts with P. This also starts with P. So any one of this can be put. You can initiate the process with any one of this, right? So we have this major substituent. Once we are done with this major substituent, go to the minor N-phenyl, and finally what is left, the thing that is left with us is found to be the parent one, that is found to be propanamide. So this is how the nomenclature stands. And finally citrate or citric acid, right? Anything, right? So this is about the IUPAC naming and all. Now we'll move on to the making of this fentanyl citrate, right? How this can be made and all, right? Okay, chalo. So now, right now we have with us the structure, right? The structure is there. We are not going to rub it off, right? Okay. Now let us find some way. So what are the possible ways by which fentanyl can be made, or what are the different, reagents which are likely to be incorporated in making what? Incorporated in the media in making what? Fentanyl citrate, right? Chalo. So let's move on. So here we have let us find the zone which is vulnerable towards the breaking and all, right? So let us just see that this is the thing, that means phenethyl, which can be inserted to a nitrogen if the nitrogen is in the state of NH. That means 1H piperidine, right? Chalo, fine. And the other end is like this. This is the found to be the other end, to which we have to add, to that end we have to add a nitrogen. So the best way is, first you should make it own, then you just replace the O with N, then just reduce it, so that the double bond will go off, and what is left in the process? NH. This is found to be the usual strategy, right? Chalo, so now the thing is that this is found to be one of the entity which has to be brought at the very first of the session, right? Then we'll move on adding or keep on adding the other substituents, right? So this is the area which can be broken down, and this is the area which can be modified, right? So on the basis of that, let us just see that what are the different reagents that can be brought here, right, to accomplish our mission, or in order to reach the destination and all, right? Chalo. So let's move on, right? So now, as I said, it's better that you should start the process with the own, right? So likewise, let us see that own means piperidine, and to that piperidine own, right? And if I want the reaction to be taking place in this terminal, definitely this particular terminal should not be left as such. Rather, this terminal has to be protected. Otherwise, equally they will respond to the reagent. So that is why it will be better, instead of making it making it NH, you can just make it like a protected one. So usually we are taking the help of benzyl protecting agent, right? Later on we'll just reprotect it, right? Right? So to this oxygen, what all I want is that a nitrogen should be the oxygen should be replaced with a nitrogen, right? Okay, so how this can be done, right? How this can be done? So it will be better if we just take the help of aniline, right? So we'll just see that what this aniline will do, because you should not forget that the nitrogen, the amidic nitrogen, one of the substituents is found to be phenyl. So likewise, we'll just place here what? Phenyl. Because later on you definitely will find that the N is holding the phenyl, right? Which is there in the in fentanyl citrate, right? Chalo. So now what will happen initially? If I just want them to react, right? How they will react? So yes, definitely there will be a reaction, and as a result of the reaction, what will happen? The H2, that means dehydration, will take place, and it is the dehydration that eventually leads to the production of what? An imino type of compound, right? Once the H2 will go off, what will happen to this nitrogen? Definitely the nitrogen will get connected, right? Because the two hydrogen has already been utilized, right? Okay, they were utilized by in the process of expelling the water, right? Chalo. So now we have got like this kind of thing, right? And as I said, finally this nitrogen has to be further linked to a carbonyl to make it an amide, right? So how this can be done? Now what next is? The next is you have to make it what? You have to make it not imino, rather amino, right? So in the process of making the first intermediate, which is found to be an imino one, to the second intermediate as amino, what you need to do? You need to do the reduction, right? Chalo. You have to add the hydrogen, right? So here the process that we are going to undertake is found to be reduction, and that should be taking place in presence of what? In presence of any reducing agent, preferentially lithium aluminum hydride, LiAlH4, right? So it is the lithium aluminum hydride that will help us, that will help the imino to get transformed into an amino, right? Chalo. So once we are going to treat the lithium aluminum hydride, what will happen to this iminic nitrogen? The iminic nitrogen will get converted to aminic nitrogen. We are approaching, right? We are approaching. Chalo. So now we have got what? The aminic nitrogen. Now to this aminic nitrogen, what you should do? What you should do to this aminic nitrogen? Later on we'll decide, right? Because we are also left with this particular portion. This particular portion has to be reacted, right? Okay. Now, so both the terminal, here we need what? Here we need phenethyl. That means one more carbon has to be added. And here the benzyl is acting as what? Benzyl group is acting as a protecting group. So definitely we are not going to insert one more carbon to this. Rather we'll just remove it, and then we'll just find some way by which we can introduce phenethyl, right? Chalo. Before that, we'll just complete this one, right? Okay. Now, what next? You just look into the structure of fentanyl citrate, right? What is there in the other terminal, right? What is there? What is the other thing that is there? That is there in the or that is there on nitrogen, right? What is the other thing? The other thing is nothing but propanamide. That means H5C2 C double bond O. This is the fragment. This is the fragment that you definitely find which is attached to this nitrogen, right? Once this will attach to this nitrogen, what will happen? This will become an amide, right? Chalo. So that means we need to acylate. We need to acylate. What? Acylate the nitrogen, right? And we all know that for the purpose of acylation or acetylation, basically we are taking the help of what? Anhydride. So we need this particular fragment. So now, as we need this particular fragment, so let us just give it a shape so that we can just use it for the purpose of the reaction. So all we need is this fragment C2 C double bond O. Now if you just try to make it or give it a shape like a unique compound, this will be something like this. So with this anhydride, definitely we can take the portion like this. All we need is only this much portion, right? So that means here, this is the one, that means propionic anhydride. This is propionic, this is not acetic anhydride. Once you'll find that the carbon number or the alkyl carbon is found to be more than 1, that means now it's 2. So that means 2 plus 1, 3, that means propionic anhydride. So this is your propionic anhydride, which will help us, propionic anhydride. What this will do, this will help us to release this particular portion, that means propionyl portion to this nitrogen, right? So once this has been given to this nitrogen, what this nitrogen will do, definitely the hydrogen will go off, leaving behind what? H5C2 C double bond O. That means we got our parent Our parent is propanamide. So we got propanamide. We are left with what? We are left with modifying only this particular terminal. That means the substituent which is attached at N1 of piperidine, which is still active, which is also acting as a substituent, right? Chalo. Now let us see, let us find some way by which we can introduce, the phenethyl to this end, right? Okay, how this can be done, right? So we got the penultimate. So now we are in the penultimate position, right? Only thing is that we need to deprotect this one. And in the process of deprotecting this one, definitely the nitrogen of piperidine will get hydrogenated, right? So that means you need to take the help of what? We love this reagent, right? For the purpose of, so this is hydrogenation we need, because once the benzyl will leave, what will happen? What will remain here? NH. So likewise hydrogenation, and that will take place in presence of what? Palladium on carbon catalyst. One of the important reagent, right, which is quite often being brought, okay, not only here but also in the process of making polynuclear hydrocarbons, right? I'm talking about naphthalene, then anthracene, phenanthrene and all, right? Chalo. So in presence of H2PDC, what will happen, right? Chalo. Once this particular intermediate has been treated with this PDC, that is palladium on carbon catalyst. Now this H2 and PDC, that means palladium on carbon catalyst, what they will do actually, this will hydrogenate the nitrogen, right? And the PDC is helping in the process of making the nitrogen to be a hydrogenated one. So now we got like this NH, right? So this we got after we are treating this with the other intermediate with, or the last intermediate with H2 with PDC, that means palladium on carbon catalyst, right? Now what next? We are left with a single, the final step. The final step, or we can say the pre-final step. Why? Because we have to add finally the citric acid and all, right? Sure. So what need to be added here? Phenethyl. How this can be added? We all know it's a, we need to alkylate it. Okay. Primarily alkylate, second to that alkyl we have an aryl, right? So let us just write this thing first. H2C and then C6H5. This is the one, right? So we need to insert this, we need to connect this to this, right? So how this can be done? We have a hydrogen here, so basically we have to bring one X, right? So that means we have to take the help of alkyl halide or aryl alkyl halide. So here the preferentially we can take the halogen as chloro. So now they will react in presence of sodium carbonate. And what is expected? The expectation is HCl will go off, leaving behind what? Leaving behind CH2. Same thing, no? Phenethyl, that means 1, 2 phenyl ethyl, right? So with that we got what? With that we got fentanyl, and what is left in the process? We have to make it fentanyl citrate. So that to this fentanyl you just add citric acid, and there will be a formation of what? Fentanyl citrate. So now after adding citric acid, what will happen? Finally you have to put the structure of citric acid as well. That is triolic acid, right? So with that we are done with the making of what? Fentanyl citrate. So this is the entire thing, or this is the final thing that you need to put, right? You need to put, or you need to come up with, right? So now let us see that what exactly we studied for the last 10 to 15 minutes, right? Okay, just hang on for a second. Okay, so here we are, right? Here we are with the entire thing, the entire scheme and all, right? So what we did initially we have taken aniline. To that aniline we have reacted piperidone actually. So this is one phenmethyl or one benzyl piperidine 4-one, right? Okay. So what happened here? Here, initially in the step 1, dehydration took place, and it is the dehydration that leads to the formation of what? Iminic one, right? Iminic one. Once we got the iminic one, this is for benzyl is for protection, right? So iminic one, to this iminic nitrogen we have introduced lithium aluminum hydride for the making of what? Aminic one. Once we got the aminic one, then we just treat this aminic nitrogen, or we have still one more hydrogen, right? Now we have replaced this hydrogen with, by acetylating what? Acetylating the nitrogen, or rather not acetylating, rather acylating the nitrogen, right? because here it's not an acetyl group that we have to introduce, we have to introduce propionyl group. So likewise, so this is NH. Now we have treated this with propionic anhydride. So what happened here? Here the propionyl group got inserted, and after that to this intermediate we just reacted, or we tried to react this intermediate with this palladium on carbon catalyst. So what happened here? The nitrogen. So debenzylation took place. It is the debenzylation that leads to the production of what? NH. Okay, we are after that one, because here we have to insert an aryl alkyl moiety as C6H5, C2H4, then Cl. So likewise, in presence of sodium carbonate, we got what? Fentanyl. And to that fentanyl, we just add citric acid, and thus there is the formation of fentanyl citrate. So hope you understood the Fracton file which is there in the entire scheme meant for the making of fentanyl citrate. So hope you have enjoyed the session. Please make it in writing, make it in pen and paper, understand the Fracton file, and so finally we have come to an end to this discussion, right? So thank you very much for your patience. And